Bill is looking for a quick way to check charging system operation. He feels that complete testing of the entire system shouldn't be necessary on every charging system job. Let's see how Larry straightens him out.
What's the problem, Bill? The only time I ever see you looking at a service manual is when you're in trouble.
No trouble, Larry, but I can't see why I have to wade through all this stuff just to check the charging system.
Well, don't let it throw you. That testing procedure is a real time saver when you're troubleshooting a tough one or making regulator adjustments. But if you only want to quick check the system operation, a visual inspection and a charging voltage check may be all that's needed. For example, when you do a tune-up, check to make sure the battery and charging voltage are within specs. You see, low voltage can hold engine performance down, even after a tune-up. On the other hand, if the charging voltage is too high, distributor points and other electrical parts can be damaged.
And the job will bounce. Okay, so how do you make an operational check?
First, check the obvious, like alternator drive belt condition and tension. Glazed, worn, or loose belts will slip and reduce alternator output.
In case of a low battery, don't forget the not so obvious, like a constant drain from a trunk light that doesn't shut off.
Good tip, Tech. Now, if the battery appears to be in good condition, then check both battery cables and the body ground cable from the engine to the bulkhead. Also make sure the bulkhead connector is pushed in all the way, and that all charging system wiring and connections are in good condition. Next, connect a test voltmeter across the battery terminals and disconnect the ignition coil primary so the engine won't start. If battery voltage does not drop below 9.5 when you crank the engine, the battery charge is high enough to allow a charging voltage test. For a quick check of charging voltage, move the positive voltmeter lead to the ignition terminal of the regulator. Hook up the ignition coil primary lead and start the engine. Now, with the engine running near fast idle speed and the system operating at normal temperature, the charging voltage should be within specs.
Okay, but what do you do if there's no charge or the voltage isn't right?
Well, if there's no charge, you can make a few quick tests to narrow down the cause. But understand, these are only preliminary checks, so don't assume that they'll take the place of the regular tests in the service manual. Now, the general makeup of the charging system is simple. There's a charging or alternator output circuit, a field or rotor supply circuit, an alternator, and a voltage regulator. Now remember, the charging circuit is normally hot at all times, so we should get a voltage indication at the alternator output terminal, even with the engine stopped. If the terminal voltage is lower than battery voltage, there's high resistance someplace. No voltage at all means an open charging circuit. If you've got battery voltage at the alternator, you then disconnect the field wire from its terminal at the alternator to take the regulator out of the field circuit. Connect a jumper wire between the field terminal and the output terminal to supply current to the alternator rotor.
Be careful with that jumper. A short to ground may burn out the fusible link. And remember that normal field current is only about 2.5 amps. If you get a hot spark when you connect the jumper to the field terminal, the rotor circuit is probably shorted.
Thank you, Tech. Now, with the field jumper in place, run the engine at moderate speed and check the voltmeter. A voltage increase indicates that there's alternator output, and the trouble is probably somewhere in the field circuit. No output indication points to alternator trouble. If the alternator seems to be okay, disconnect the field circuit wire from the ignition terminal of the voltage regulator. Then connect the output terminal end of the jumper directly to the field circuit wire. Again, run the engine and check the voltmeter. If you have a charge indication, it means that the field circuit itself is probably okay, and you'll have to check out the voltage regulator.
What if the system charges too much or too little?
Well, that opens a whole new ballgame. The cause may be high resistance, a short, or an open somewhere in the system, and that's where the service manual tests come to the rescue.
Can't you simply adjust the voltage regulator?
Not on your life, Bill. Adjusting the regulator before you make the other tests can really foul things up. Larry, why don't you give Bill your slant on making the charging system tests? It never hurts anyone to review from time to time.
Yeah, sounds like a good idea, Tech. we can do a checkout on this job here. Charging system tests are made in 5 steps: battery, field circuit resistance, charging circuit resistance, current output, and voltage regulator operation. Be sure to follow this sequence so you'll know you're getting accurate indications. You see, test specifications for alternator output and regulator operation are based on knowing that field circuit and charging circuit resistances are within specs. The regulator setting spec, in turn, is based on the output of the alternator and a fully charged battery. Now, beginning at the battery, there's always the possibility that lead oxide is formed under the cable connector clamps. This thin, dark oxide coating can build up enough resistance to upset regulator operation and may put the whole electrical system out of business. As a regular part of a tune-up or any electrical system test, always brighten up the battery posts and inner surfaces of the cable clamps with a wire brush, so you'll be sure there's no high resistance at these points. And while you're at it, check the terminals at the other ends of the cables for tightness and general condition. Don't forget the body ground cable connections at the engine and bulkhead. Be sure the cable terminals don't turn as they're tightened, or you may break the cable strands. After inspecting the cables, we begin the charging system tests by checking battery charge and capacity. If you find a partial charge, sulfation, or defective cells, you'll have to install a good, fully charged battery before you go any farther.
How about simply clipping on a good battery with booster cables?
That won't work unless you disconnect the low battery. Otherwise, the good battery will discharge into the low one and drop the voltage. Also, the regulator will keep the alternator output higher than we want for testing, as it tries to charge the low battery. If the battery is in good shape, we can go on to the field circuit. The field and charging circuits share a common path from the battery to the junction terminal of the starter relay, through the bulkhead connector, and to the ammeter. From the ammeter, the 2 circuits are separate. The field circuit continues from the ammeter to the ignition switch. From there, it passes back through the bulkhead connector to the regulator. It then goes to the alternator field terminal and through the rotor windings to ground. Since current normally flows through the field circuit when the ignition switch is on, we can check circuit resistance without running the engine. We measure field circuit resistance by checking the voltage drop across the circuit from the battery to the voltage regulator, with the primary ignition wire disconnected from the ballast resistor. The voltage drop indication is small, so we use a voltmeter with a scale graduated in tenths of a volt. Any questions at this point, Bill?
Why do you disconnect the primary ignition wire from the ballast resistor?
When the wire is connected, the ignition primary and the field circuit both draw current when the distributor points are closed. This forms a parallel circuit and allows enough extra current flow to upset our resistance test. Here's why. Any extra current heats the field circuit and increases its resistance enough to produce misleading voltage drop indications. Now, for the actual field circuit resistance test, the positive lead of the voltmeter clips to the positive post of the battery, and the negative lead goes to the field terminal of the voltage regulator. This hookup doesn't test alternator rotor resistance. We'll check that later in the charging circuit test. The field circuit voltage drop should not exceed 55 hundredths of a volt. More than this indicates high resistance somewhere between the battery and the regulator field terminal. Make sure all lights and accessories are off, so there isn't any extra current flow. To locate points of high resistance, touch the negative voltmeter lead to each connection in the field circuit. When you reach a point where the voltage drops sharply, the trouble is between that terminal and the last point tested.
A voltage drop of 1 to 2/10 across the regulator is normal, so don't condemn the regulator for a 2/10 drop. To save time, you can check from the regulator to the bulkhead connector first, and then work backward from the battery to the starter relay. Any high resistance which remains is in the bulkhead connector or in the ammeter and ignition switch circuit. Wiggle the wires and connectors while you watch the voltmeter. Movement of the pointer can mean you found a loose or dirty connection or a broken wire. Don't overlook the possibility of poor connections in the bulkhead connector itself. And let's not overlook the fact that we'll run out of sound if someone doesn't turn the record right now.
Now, as I mentioned earlier, the field and charging circuits share a common path to the ammeter. But from the ammeter, the charging circuit goes back through the bulkhead connector to the alternator output terminal and ground.
Right here, I'd like to point out that the car ammeter does not indicate alternator output. It only indicates current flow in or out of the battery. When the battery is fully charged, it's normal for the ammeter to show only a slight charge.
A good point, Tech. And current flow in the charging system itself is always from the alternator to the battery. Current flow from the battery to the alternator is prevented by the rectifiers. For this reason, we make the charging circuit resistance test with the engine running and the alternator charging. The charging current must be controlled or the voltage drop indications will be misleading. Therefore, we will cut out the voltage regulator and control the current output by adjusting engine speed. Now, since the entire charging circuit is hot, always disconnect the battery ground cable before setting up for the circuit test. If the output terminal or wire is accidentally grounded, the charging system or the test equipment can be badly damaged. For the test, connect a test ammeter in series between the alternator output terminal and the charging circuit wire. Then disconnect the field wire at the alternator and connect a jumper between the output terminal and the field terminal. Also, disconnect the regulator ignition wire. The jumper between the output and field terminals completes the test ammeter circuit to ground through the brushes, slip rings, and rotor winding when the battery cable is reconnected.
With the rotor standing still, a field current draw of less than 2 amps indicates high resistance inside the alternator, possibly caused by worn brushes, bad slip rings, or a poor ground at the alternator frame. If the reading is more than 3.5 amps, it means you may find an internal short in the insulated brush lead or in the rotor winding. Now back to you, Larry.
Okay, Tech. If the alternator field circuit resistance checks out, we can complete our charging circuit test hookup. Connect the positive voltmeter lead to the charging circuit wire along with the ammeter lead. Clip the negative voltmeter lead to the positive battery post. Start the engine and adjust the speed to get 10 amperes on the test meter. The voltage drop should not be more than 0.3 of a volt. If the drop is higher, you'll have to check all circuit connections.
If resistance in both the field and the charging circuit is okay, you're ready for the alternator output test. The test specs call for a specific current output at a specific speed.
Right, Tech. For the output test, the voltmeter is connected across the circuit to the charging circuit wire and ground. The regulator remains disconnected from the circuit, and we leave the test ammeter and the field jumper connected, as in the previous test. Connect a carbon pile across the battery to provide an adjustable load, so we can maintain the voltage specified for the output test. Adjust engine speed to exactly 1250, and load the battery with the carbon pile to get exactly 15 volts on the voltmeter. Then read the current output. Be sure to remove the carbon pile load from the battery as soon as the test is completed.
The engine speed and voltage specs are the same for all of our alternators, but the current output is not. Your service manual gives you the right current output specs for the alternator you're testing.
What if the current output isn't within specs?
You'll have to remove the alternator for a bench check. Right now, we're ready for the voltage regulator test. For the voltage regulator test, we first remove the field jumper and reconnect the regulator field wire to the alternator field terminal. We also reconnect the wire removed from the regulator ignition terminal. In addition, the positive voltmeter lead is moved to the ignition terminal of the regulator. We leave the ammeter and carbon pile connected as in the current output test, but the carbon pile is turned off during the warm-up before the test. Start the engine and again adjust the speed to 1250. Load the system by turning on lights or accessories until the test ammeter shows 15 amps. Then run the engine long enough to warm up the charging system.
Do you have to run the engine for 15 minutes like the manual specifies?
Yep, you sure do. The voltage regulator was out of the circuit during the other tests, and it's relatively cold. The regulator is temperature sensitive, so the charging voltage varies during warm-up, but stabilizes at normal operating temperature. In the specs, you'll notice that charging voltage depends on regulator temperature, measured 2 inches from the regulator cover after the warm-up. Remember that the cover must be in place for all regulator tests. And one more thing. Be sure to cycle the regulator before you take each test reading. The easiest way to do this is with a handy little cycling switch you can make for yourself. The service manual tells you how. Want to take it from here, Larry?
Ready and waiting, Tech. The first part of the test checks voltage control with the regulator operating on the upper contact. This is the normal condition when the charging system is carrying a high electrical load at relatively low speeds. Recheck the engine speed to make sure it is at 1250 and adjust the carbon pile to maintain the specified 15 amps. Then check the voltage and regulator temperature against the specifications. If you find that the voltage is higher than the maximum spec, armature spring tension is probably too high. After adjustment, be sure to replace the cover and cycle the regulator before retesting. When you find the voltage below the minimum specification, armature spring tension is most likely too low. If the voltage indication is within the spec limits, you can then go on to the second part of the regulator test. For this part of the test, you raise the engine speed to 2200, turn off the lights and accessories, and adjust the carbon pile load to reduce the current from 15 to 7 amps. After you cycle the regulator, the voltage should be at least 0.2, but not more than 0.7 of a volt higher than in the first step. If the voltage is within limits, the regulator is working properly and the testing job is finished.
Hey, suppose the voltage is higher or lower. What then?
If the voltage doesn't meet the specs on this test, either the point gap or the air gap is probably incorrect.
What's the reason for the fusible wires in the voltage regulator?
The upper contact fuse wire protects the field circuit, especially against the short to ground in the field wire to the alternator or in the rotor part of the circuit. If the upper contact fuse wire is burned out, you'll get no output in the first part of the voltage regulator test. With the fuse open, you lose the part of the circuit that supplies high alternator field current to produce full alternator output. On the other hand, high output in the second part of the regulator test could mean an open lower contact fuse wire. And that's my story on charging system diagnosis, unless you have some questions.
Just one, Larry. When are you going to give me a lesson on the new insulated brush alternator and the electronic voltage regulator?
It just so happens that this month's handy-dandy reference book includes detailed instructions for testing the new alternator and regulator. However, we can take a minute or two right now to explain why the test hookup for these new charging system units is different. How about it, Larry?
Sure thing, Tech. In the first place, in a conventional system with electromechanical voltage control, the regulator is connected into the field circuit between the insulated field brush of the alternator and the positive battery post. The grounded brush completes the field circuit to ground. In the new insulated brush alternator, both brushes are insulated. The former ground brush is now an insulated positive brush which connects directly to the rectifier heatsink. This means there is always a direct connection between the positive brush and the positive terminal of the battery. The new electronic regulator is connected to the field brush, but this has become the ground side of the field circuit. In other words, the new regulator is still in series with the rotor, but it's now in the negative side of the field circuit instead of the positive side.
And that's why the two types of alternators and regulators are not interchangeable. Also, when checking the new system, the jumper used in the current output test is connected from the field terminal to ground, instead of connecting it between the field terminal and the output terminal. Of course, the new regulator can't be adjusted or repaired, so servicing and testing that part of the charging system is greatly simplified. You can test regulator operation without a warm-up, and you'll find that complete system testing is also simpler. And now, this is where we all thank Larry and Bill for giving us a new slant on charging circuit diagnosis. Be sure to read about the new alternator and regulator in your reference books, and use your service manuals and service bulletins. See you all at the next meeting.